Hi, we're going to take a look at how to read inequalities from a graph. In order to do this, you'll need to find plotting and reading straight line graphs of both these forms and know how basic inequalities work. I'm going to cover all these things but fairly quickly. So let's get started. Basically got 4 skills to learn as shown on the screen now. First one, reading horizontal and vertical graphs is really easy. Just with a few basic tricks. So going through each one at a time. For each graph we need to check 2 things. First of all, which axis is it cutting through? For this one we are cutting through the x-axis, so it's going to be x equals. Next is what number does it cut through? In this case it's -2, so the equation is x equals -2. And that's it, that's all you need to do. Just remember those 2 things. So this one, what axis is it cutting through? It's cutting through the y-axis and it's cutting through the number 4. Okay, same one here, cuts through the y-axis again, and this time it'll be y equals -2. Okay, really straightforward skill, but I see a lot of people forgetting it, so make sure you do not forget those 2 things. Okay, next section. Reading graphs in the form y equals mx plus c. There are basically 2 halves of this. You've got to find the y-intercept, look at that first, and that will give you the value of c. So for the first graph, here's my y-intercept, so I know that c will be -1. Okay. Again, a really straightforward skill. Let's break it down. Let's take it fairly slowly so you're not making any careless mistakes. Okay, now we've done that, we need to move on to finding the gradient. Gradient for these graphs is probably best defined as, if I go 1 square along, how many squares up do I go? So let's go through these 3 examples. So here, I can say any point. It helps if you start on a corner point. So here, if I go 1 square along, I go 2 squares up. So here the gradient is 2. And I should have mentioned the gradient here tells you the value of m. So that means this graph will look like y equals 2x plus something, plus whatever c is. We'll come back to that in a second. Next example. Here we want the gradient. So let's take any points on a corner. This will do. And here it's slightly harder, because if I go 1 square across, it's not obvious how many squares are going up here. I don't know what number this is exactly. So let's try and think what else we could do. If I look a bit further ahead, I notice that I've got a corner point here as well. So what I can do instead is go from this point to this point. Now this tells me that I've gone 3 squares along and 1 square up. So therefore, each 1 square long I've gone, I must have gone 1/3 of a square up. So it'll be 1/3, 2/3, 1 whole. So here the gradient is 1/3, which means this equation will start y equals 1/3 x plus something. Okay, slightly harder. Make sure you're okay with that idea and how that logic works over here. Okay, last example of finding gradients. We have one more. Again, let's take any corner point. I'll use up here actually. And again, we follow the same rule. I go 1 square along, and how many squares up do I go? So here it's a bit different. We're not going up, we're going down instead. If we're going down, you want to think of that as going up by a negative amount. So here I've gone up by -3. So therefore the gradient is -3, and this graph will start y equals -3x plus something. Okay? Make sure you're finding both those 2 skills of finding the y-intercept and finding the gradient. Let's bring it together, just for 3 examples, and we're now going to find the whole equation for each of these 3 lines. So for each of them, they're going to be of the form y equals mx plus c. C is always really easy to work out. C is this number here, it's where it cuts the y-axis. Again, always cuts the y-axis. So this will end in a +2. Now we need to find the gradient. Gradient is, if I go 1 square along, how many squares up do I go? Well, here we're going down, so that means I'm going up by a negative amount. And if we look, if I go 2 squares across, I go 1 square down. So for each 1 square I go across, I must have gone half a square down. And again, because we're going down, that means it's minus. So it's y equals -1/2x plus 2. So the gradient was -1/2, and the y-intercept or the y cut was +2. Okay, moving on. So again, it's going to have that same form. It's going to look like y equals mx plus c. First of all, let's find c, 'cause that's always the easiest. Here, the y cut is 1, so it ends in a +1. Now I need to find the gradient, so I use the point again. If I go 1 square along, I have gone 3 squares up. So this graph is going to be y equals 3x plus 1. Okay. Last one to do. Again, same basic form. If you keep writing this down, it does make it a bit easier. Start with a plus c. That's going to be plus 3. And now we have a slightly awkward gradient again. I can start from here. Again, I don't know how many squares have gone up here, but like last time, if I go 3 squares along, I go 1 square up. Therefore, that means each square I've gone along by, I have gone up by a third of a square. So it's y equals a third x plus 3. Okay, hope that made sense. Just need one more skill before we tackle actual questions. And that's when we read graphs, and we're going to write it in this form here, ax plus by equals c. The main reason is that here the gradients aren't too obvious. I mean, some of them are, but this works for basically any line and tends to be a bit quicker, but just gives the answer in a different kind of form. Okay, so the form is going to be ax plus by equals c. What we're going to do to work this out, we're going to use these 2 points here. We're going to use the point where it cuts the x-axis and where it cuts the y-axis. First thing we can do is we can work out the c over here. This c will just be these two numbers times together. So here I cut at 2, here I cut at 3. That means c is going to be 6. It's going to be something x plus something y equals 6. Now let's fill them in. I know here that the x coordinate is 2. What I want to do, I want to work out what times 2 gives me 6. Okay, and that'll tell me what the value of a is. So here, 3 times 2 is 6. So this will start with 3x. Okay, so you look at this x coordinate and think what times 2 gives me 6, which is 3. We do the exact same thing for the y's. Here the y cuts at 3. So what times 3 gives us 6. And in this case it's 2. 2 times 3 is 6. So it's going to be 3x plus 2y equals 6. And again, as a slight shortcut, you basically notice that this 3 and the 2 have basically swapped places. So what I mean is the 3 was where we cut through the y-axis, and that's a number in front of the x's. And this 2 was a number where it cut through the x-axis, and that's a number in front of the y's. So there are some slight shortcuts to this. Okay, slightly more awkward, so we'll try a few more of these. So here, it's the exact same thing. Let's write down the basic form. Ax plus by equals c. And we're going to start by working out c. So c is always these two numbers times together. So I've got 5 and I've got 2. That means this will be something x plus something y equals 10. Now let's work them out. I know my x coordinate is 2, so I want something times 2 to give me 10, which is 5. So it'll be 5x. And here I want something times 5 to give me 10, which is going to be 2. So it's 5x plus 2y equals 10. And note again, it is just these two numbers, but they're kind of swap place. So this is my y cut, goes in front of the x's. This is my x cut, and it goes in front of the y's. Okay, hopefully that wasn't too confusing for you. I'm just going to do 2 more, just so you get really confident how they work. So let's start as we always start. Your first step is always just to write down this sort of general form. Next we can work out c. I want to times together these two numbers. Okay. When doing this, it makes life a bit easier if you just ignore any minus signs. Okay, it doesn't change anything overall, but it makes the equation look a lot nicer. So I'm going to pretend that here I've got 3. I know it's minus 3, I'm going to pretend it's 3. So this is going to be something x plus something y equals 15, because this point here is 5. Now we do the exact same thing. For the a, I know it cuts through the x-axis at 5, so what times 5 gives me 15, which is 3, so I want 3x. And I'll do the same thing here, but now it's a bit different, because now I want something times minus 3 to give me 15. And something times minus 3 to give me 15, that is going to be minus 5, because minus 5 times minus 3 is 15, because two minuses times together gives you a positive. Okay, and that's your form. So slightly more awkward. My key piece of advice is always make sure that this number here is positive. If you have a negative, it will still work. It just tends to confuse you later on, where you don't need to be confused in that way. Okay, last example. We should be fine with this now. We start with the form ax plus by equals c. My numbers are 2 and 7, or 2 and minus 7, but I pretend it's 2 and 7. Times them together, that gives me a c of 14. Next I'm going to work out a, so I find my x cut. My x cut is minus 7, so what times minus 7 is plus 14? For that I need minus 2, because minus 2 times minus 7 is plus 14, so this will start with minus 2x. Then it's plus by, so the y cut is 2, so what times 2 is 14 is 7, so it's minus 2x plus 7y equals 14, and that's the equation of this line. Okay, it is worth mentioning for both these equations, we can also use y equals mx plus c, but that takes a lot longer just for the, in essence, the same answer, so it's a lot quicker to use this slightly quicker method rather than go through the whole problem trying to find what gradient is going on here when it's just not really that obvious. Okay, those are the skills we need to know. We can now look at the actual stuff we need to do in, which is looking at the main rules of inequalities and how we define a region given by inequalities. So key rules. Whenever you're given an inequality, so say I had the inequality y is greater than x, or greater than or equal to x, that means if I draw that line, because these are greater than signs, I'm going to be above that line. Okay, and it's the exact same the other way around. If these were less than signs, I would then be below the line. Okay, lastly, some convention we have in maths. If it can equal that line, so it's either greater than or equal to or less than or equal to, we use a solid line. If it does not equal it, so either just greater than or less than, we then use a dashed line. So if this was y is greater than x, we would have a dashed line instead to show that it's not equal to that. Okay, let's see some typical exam style questions. So we've got two questions to try. In both of them, we're given some sort of region R, and we're asked to write down the three inequalities that are going to define that region. So basically we've got 3 lines here that are bounded inequality, and we need to define each of those. So let's start with equation 1. Okay, again, this we can do 2 ways. We can use y equals mx plus c, or we can use ax plus by equals c. Which you use really doesn't matter. I'm going to pick the new way, just so how it works. Okay, so for this, we times these two numbers together. So 6 times 6 is 36. We then need to work out 6 times what gives me 36, which is 6. So I have 6x, and the exact same for the y's. So when I have this equation is 6x plus 6y equals 36. That's the equation of my line. I will simplify this. Everything here divides by 6. So I can just rewrite it as x plus y equals 6. However, that's the equation of a line. What I want is an inequality. So I look to my guide up here. We want to be below the line, and we have a dashed line. So below the line and a dashed line tells me that this inequality here is x plus y is less than 6. Okay? Let's move on. We've got 2 more equations. Equation 2. So the equation of this line is a vertical line, so it's going to be x equals, because it cuts through the x-axis, and it cuts at minus 1. So the equation of this line is x equals minus 1. But again, you want an inequality, and if we look at the graph, all my x values, are greater than minus 1. Also, it's a solid line, so it's going to be x is greater than or equal to minus 1. Then do the exact same thing as equation 3. It cuts through the y-axis, it cuts at minus 3. So this line has an equation of y equals 3. We wanted an equality. We're going above this line, and it's a solid line, so it's y is greater than or equal to 3. And if that was an exam, those would be your 3 answers. So these 3 inequalities here define this region R. Okay. One more. So here we've got a couple more diagonal lines, makes it a bit harder. Let's go through it. So first for equation 1, I'm going to have it in the ax plus by equals c form. Times together these two numbers, ignoring any negatives. 3 times 4 gives me 12. I can then work out what a is going to be. So what times minus 4 gives me 12? That is minus 3. So it's minus 3x. I can then work out b. What times 3 gives me 12, which is 4. So this equation here is minus 3x plus 4y equals 12. I'll get rid of that for now. Equation 2, I'll do the exact same way. Again, for both of these, you could also use y equals mx plus c. Sometimes it's easier, sometimes it's not. So just pick one, you can always change if you have to. First step, times numbers together. That gives me equal to 32, because 4 times 8. Then working out a, so what times 4 is 32, which is 8. Then working out b, what times 8 is 32 is 4. And this again you can cancel down because you have a common factor of 4. That will give you 2x plus y equals 8. Okay, and that'll be my equation 2. What I haven't done now is change any of these to inequalities. So for both these lines, we're going below them. So they're both going to be less thans. Here is a dashed line, so we don't want it to equal here, but this is a solid line, so it can equal 8. So it's 2x plus y is less than or equal to 8. Just one more, and it's an easy one. This is a horizontal line. It cuts through the y-axis, so it's y equals, and it cuts through at minus 1. Also, we're above this line, and the line is solid, so therefore y is greater than or equal to minus 1. Okay, and that's it. That's all we're learning today. Key things, or basically newer things, is this new form, and also don't forget all the rules given in this little box here. Okay, hope that made sense to you, and thank you for listening.